Welcome to the NPTEL course on marine propulsion. I am Anirban Bhattacharya, Assistant Professor at the Department of Ocean Engineering and Naval Architecture at IIT Kharagpur. When a ship moves through the ocean, it has to overcome the resistance from waves and wind, and from that point of view, a propulsion system is required to propel the ship forward. Now, the purpose of that propulsion system is to provide thrust for the marine vessels to move at the desired speed. The most popular device used for marine propulsion is a screw propeller, as shown in this picture. In this course, we will cover the different aspects related to marine propeller hydrodynamics and look into marine propulsion in general from the point of view of both design analysis as well as experimentation and full scale powering calculation. If we look into the contents of this course, we will start with a brief introduction, the geometry of screw propellers, and then cover the theories which relate to propeller action, open water characteristics, which is basically the performance of propellers without the presence of ship hull, and then study the hull propeller interaction. That means how the propeller behaves behind the ship and the different efficiency components involved in ship powering calculation. Next, we will cover model tests, basically propeller open water test and self propulsion tests which are performed in the towing tank, and how we extrapolate the results of these tests to get the ship powering calculations. Now, engine propeller matching is a very important component which relates the ship engine to the propeller performance. Other aspects of propulsion like propeller cavitation and propeller blade strength will also be discussed. Then propeller design, where we talk about methodical series design of marine propellers and also other factors which influence the design of propellers in general, geometric factors which are important for designing propellers. And finally, we will discuss other propulsion types like controllable pitch propellers, ducted and podded propellers, and some unconventional propulsors like water jets, foils, etc., and thrust augmentation devices, for example energy saving devices which can improve the propulsion performance of marine vessels. So, if we look into the different perspectives of this course in general, we will have a theory component where the basics of propeller action will be discussed, mainly the hydrodynamics of marine propellers, and then calculations related to ship powering from both point of view of model test results as well as full scale ship powering calculations, and calculations related to cavitation as well as propeller performance, and finally some practical aspects which is related to the design of ship propellers and also applications with respect to certain types of marine vessels. Different propellers, whether it is the screw propeller or some unconventional propeller devices, are used for specific vessels where depending on the operation as well as their performance characteristics. These aspects will be covered in this course, which will give a practical understanding for marine propulsion in general. So, this is meant as a beginner's course in marine propulsion, which will serve as an important course for both naval architecture students as well as practicing persons from the industry. So, if we look into the enrollment perspectives, both undergraduate and postgraduate students of naval architecture as well as practicing naval architects and engineers from the industry and R&D institutes can benefit by enrolling in this course. The prerequisites for this course will basically involve completion of second year UG curriculum, which includes basic knowledge of hydrodynamics as well as basic ship theory, introduction to concepts of naval architecture and ship resistance concepts. I welcome you again to this course and wish you good luck. Thank you.